Hello everyone, I hope everyone's having a great day when they start watching this video. Today we're going to start talking about chemical equations, how to read them. I know I've given you guys kind of a bunch of examples and some brief explanations, but we're going to explain each part of it now after we've seen a few different ones. So, our chemical equations. The questions I have for us today is, how are ice, water, and water vapor different? And then what are our three main phases of a substance? So when I think about ice, water, and water vapor, ice seems to be the most cold. It's also the hardest of them all. Water is liquidy and it will fill the volume of a container you put it in. So if you put water in just in a cup, it fills up the cup. But if you pour it on the ground, it goes everywhere, is what I mean by that. And then water vapor just kind of goes into the air and leaves and goes really far away. And then our three main phases, we'll talk about them today, are gas, liquid, and solid. So our goals are going to be able to compare our two types of chemical equations and then understand just the symbols that we use in our different chemical equations. So I have a video for you guys, and I will link it in the same place as always. So please watch that. But what we're going to do together today is go through this fun simulation. So this will show us what each different state looks like. We have our three different states. So we have a solid state, and let's look at what this simulation is telling us. We have neon. Neon is a type of gas. It's actually, let me show you guys where it is on the periodic table. Neon is number 10, and it is right here on our periodic table. So when it's in the solid phase, everything is really close together. Each circle is one neon atom, so they're all really close together. As we go to a liquid phase of neon, things are a little bit more spread out, but they're still all at the bottom of this chamber, and a few rise up. As we have a gas, they're everywhere. So this is a lot like how the air looks around us right now. If we had each molecule be a little circle. When we have liquids like in our water bottles, they all stay at the bottom of the container. And then if we have a solid like our desk, they stay in the shape they're supposed to be. But let's look at how it changes as I raise up this heat. So I can put a little flame next to it, and it starts changing. Just a few at a time go into from a solid into a liquid, and then all the way to a gas phase. So we can also cool it back down if we put ice on it to cool it down. And we can even, all the things are going to go back to being close together, and we can even see our temperature changing right here. So as we keep cooling things down, they all start to sink back down. This is maybe more of a liquid phase. And then it's changing back into a solid phase, staying really tight and close together. So we can do the same thing with water. Same thing, our solid is close together and kind of has a nice structure to it. Our liquid is all at the bottom of our container, and then our gas is everywhere. So let's cool it down. So starting in the gas phase, as we cool things down, they start to get closer together, start to look more like the liquid, and then as I get even colder, they spread out and look a lot more like the solid did. So that's just an idea, a way to think about things. These other ones are simulations that are a little complicated for what we're learning, so we'll just stay there for today. So let me do this so it looks nice. Okay, so please go watch this video. It does a good job of explaining some of the basics of our chemical equations. But we have two main types of chemical equations. We have either a word equation, which uses, of course, uses words for our compounds, and then also addition signs and an arrow. And then we also have methane. So our example is we have methane, oxygen, plus oxygen goes into water and carbon dioxide. So we can see that the left side of the equation, we have two things coming together and they're added together. So just like in math, anytime we add something, we can switch these. So oxygen plus methane is the same as methane plus oxygen. And they react together to get water and carbon dioxide. Our symbol equations are a little bit different. These are the ones that I've exposed you guys a lot to. So this is using symbols for compounds. We have some numbers, we have different phases, we have addition signs, and an arrow. So this is the one we mainly focus on. So our example here is we have CH4 and this little G plus 2 oxygen, or O2, in a little G with an arrow, and then we have a 2 H2O with an L plus CO2 and a G. So that is the difference between our two. Word equations maybe are easier to understand, but our symbol equations tell us a lot more about what is going on. So our symbol equations, or different symbols in our symbols equations, are really important. So each compound has a phase written next to it. So G stands for gas, L stands for liquid, S stands for solid. Great, those are 3 different states. But we also have an AQ that sometimes gets put in. And this means aqueous. Aqueous is a fancy word or fancy way to describe that something is dissolved in water. So we could say, for example, that salt water could be written as NaClAq. So salt water is just normal water with some salt in it, and it is abbreviated as NaClAq. So we also have a couple different kinds of arrows I want you guys to know about, just to understand. So different arrows have different meanings. A single-headed arrow means irreversible. So that looks something like this, or down here below we have this nice big colorful arrow. So irreversible means that it only goes one way. So as soon as this reaction happens, it doesn't go backwards. It can only go forwards. And this is an example of a combustion reaction. So once we set something on fire, we use oxygen, and then it goes back to, or it goes into be CO2 and water, and goes back into energy. So we can't collect the smoke from a fire and put it back into wood. It is always gone. The next type we have is a double-headed arrow, which does mean reversible. And this means these reactions can happen both forward and backwards. So, for example, this is showing a reaction where our electrons move from this double bond, these 2 lines, to the other side of our molecule. So, just as easy as it is for the reaction to go this way, it can go backwards the other way. So it happens a lot back and forth. So the 2 kinds that we're really going to be focusing on, though, are our irreversible. So we're going to be focusing on irreversible ones, where it's always, our reactants always stop at our products and just stay there. And then we're going to be focusing on symbol equations that look like this last one. So I hope that makes sense. We'll be doing a lot of different work, and I'll be showing you guys a lot of more examples about all of them as we keep going and learning about chemistry. So if you have any questions, always please let me know.